All right, so these are our day one notes on normal distribution. All right, so let's talk about what a normal distribution looks like. So this diagram right here is an example of what normal distribution looks like. Okay, so it is a bell-shaped curve and it's symmetric with respect to the mean. So I'm just going to draw another sketch of this right here. So I'm going to draw a horizontal line and then I'm going to draw the best that I can. Ooh, it's not terrible. Okay, it's not terrible. All right, so the mean would be directly in the middle. Okay, and it actually says it as one of the bullet points, I believe. The mean, median, and mode are all equal and they are in the center. So we use a variable for that, and that is mu. It's a Greek letter. So once again, this right here, mu, that is the mean. Okay, and you need to know that. All right, and then let's read these bullet points instead of me saying them and not realizing they're happening there. So the graph is bell-shaped with symmetric to the means. That means half the data is to the right, half the data is to the left of the mean. Mean, median, and mode are all equal. They're at the center. The curve is continuous. So if you notice, I didn't touch down here and go anything like that because it keeps going on forever and ever. So that's why that there's arrows. Well, this one got chopped off, but there's an arrow here on the end, okay? Because it goes on forever and ever. The curve approaches but never touches the x-axis, so that's why I drew it the way I drew it. And then the total area under the curve is equal to 1 or 100%, okay? So what you're going to end up finding, which I'll explain in a second, is you're going to find 3 standard deviations to the right and 3 standard deviations to the left. So what we're going to end up having is we're going to have 1, 2, 3 standard deviations to the right and 1, they're supposed to be symmetric here and I'm not doing the best job, 1, 2, 3 standard deviations to the left, okay? Standard deviation, we use the Greek letter sigma, okay? It's lowercase sigma because we used sigma before, but this is a lowercase sigma. So that's sigma, this is sigma, okay? And then this is also a standard deviation here, okay? Keeps going and going. So this Greek letter right here is standard deviation, which is sigma. I gotta write slower. There we go. Okay. All right, so this here says given a normal distribution, we use the empirical rule to find some approximate probabilities. So if you look, we have like we said before, we have the mean, and then we have 1 standard deviation to the right, 2 standard deviations. That's why it's 2 standard deviations, 3 standard deviations, right? And then we also have that to the left, and that gives us these percentages, okay? So we have this is the empirical rule. It's also called the 68, 95, 99.7 rule. And that's to help you remember the percentages. So empirical rule or 68, 95, 99.7 rule. So the reason it's called that is because 68% of the area is between 1 standard deviation of the mean. And how we write that is the mean minus 1 standard deviation, the mean plus 1 standard deviation. So 68%, which is this right here, that's where 68% of the data falls, right? So since this is symmetric, that means 34, oops, I don't want to put that in highlighter, I'll put it in blue. 34% of the data is here and 34% of the data is here because 34 plus 34 is 68, right? All right, then we also, and I'm going to change colors here so I can color code it kind of in the picture. 95% of the area is between 2 standard deviations, right? So I'm going to use my highlighter again. This is 95%, right? So if we want to figure out this area and this area, we can use our calculator to do that. And then I just memorize the numbers so I don't ever have to do it again. I highly suggest you do that too, but I'm going to show you how to get those numbers in case you forget them. Okay. All right, so if I want to figure out those 2 areas, I know that it was, let me clear that out, 100 minus the 68 we already used, which is 32, right? Or sorry, 95, it's not 100. 95 minus the 68 that we already used, which is 27. And then there's 2 areas, so if I divide that by 2, it's 13.5. So each of these is 13.5% and 13.5%, right? Okay, now it doesn't look like it, but I need to fix, no, it's not fix it per se, I need black here. But there is another line right here, and this keeps going, okay? And there is another line right here, and this keeps going. It just got so close that you could hardly see it. So I'm gonna fix it, and so should you. It's not really fixing it per se. Okay, so let's keep going here. I'm gonna change colors again. I'll do purple this time, okay? All right, so it's a 68, 95, 99.7 rule, or the empirical rule, and that's 97% of the data falls within 3 standard deviations. So once again, it was 99.7 minus the 95 that we already used, and then it's 2 equal areas, so divided by 2, and we have 2.35 and 2.35. So this is 2.35%. And this is 2.35%. Oops, 2.35%. Okay. Now remember, the whole curve is 100%, right? So 100% minus the 99.7 and divide that by 2, we have 0.15% left. So let me fix that. Put that in orange. This right here is 0.15%, and this right here is 0.15%. And then that makes up 100%. Okay? All right, so, and that does not change. That is the normal distribution. So here's how we're going to use this for problems. We're going to do 2 problems with it. And it says SAT math scores are normally distributed with a mean of 514 and a standard deviation of 113. What's the probability of randomly selecting a student with a score between 288 and 627? So I want to show you a couple notations really quickly. So when you're talking about normal distribution, we use the capital letter N, and then you write whatever the mean is here, and then the standard deviation is here. I'm going to try to continue to use that. And then when we do probability, if we're saying the probability is in between 2 numbers, we can say X is in between those 2 numbers. If you don't write it down, you're not going to get any points taken out, but I'm going to try to remember it so that when you see that in the future in your math career, that you know what it means. Okay, so once again, we're looking for the normal distribution, or so it says it's normally distributed with a mean of 514 and a standard deviation of 113. And we're looking for the probability that a student selected will be between 288. I'll say X is in between 288 and 627. Okay, so what we're going to do is we are going to draw our normal bell-shaped curve here. Okay. Ugh, sorry. I didn't mean to get so upset with the way mine looked, but whatever. And if you want to copy and paste this so you can use it again once you draw it, you can. I'm going to do that because I'm just going to save myself some time in my video here. All right, so remember, this right here is going to be the mean. And then you have to do 3 standard deviations to the right. 1, 2, 3. And then 3 standard deviations to the left. 1, 2, 3. And so I'm going to do myself a favor and copy this just so I have it. And just know in your head that if you're copying it, you have to know that you're using that, right? All right, so our mean is 514. So I'll put that there. And then I'm going to do 3 standard deviations to the right. So I'm going to do 514 plus 113. That's 627. Plus 113. That's 740. Plus 113. And that is 853. Okay. And then I'll do 514 minus 113. 401. And then I'm going to subtract 113 from that. Oops. Hit enter. I got 288. Now, a little trick that you should know. See how it says answer minus 113? If you hit enter again, it's going to do it again, which is nice. and that's 175. Okay, so now I'm going to actually read the question because I already forgot what it asked. It says, what's the probability that a random selected student will score between a 288 and a 627? So here's 288, here's 627. So I want to know what this area is. So if you haven't memorized, life's going to be way easier. If you don't, you can figure it out every single time. But I have it memorized. This was 34%. This was 34%. And this was 13.5%. But once again, if you forget those numbers, you can figure them out again because it's the 68, 95, 99.7 rule, and you can figure those out, right? So now what I'm going to do is I'm just going to add those together. 13.5% plus 34 plus 34, you can say plus 68%, however you want to look at it. You can put that in your calculator, 68 plus 13.5, or you can do mental math, either one. And the probability is 81.5%. It's not too shabby, right? It's not, if you know those percentages, if you have that in your head, this is going to be so easy. If you don't, you're going to have to calculate them real quick, and it's still pretty easy. All right, the next one says, the heights of 880 students at Lincoln High School are normally distributed with a mean of 67 inches. So I'm going to write down normally distributed with a mean of 67 inches and a standard deviation of 2.5 inches. Approximately how many students are more than 72 inches tall? Okay, so what I'm going to do is I'm going to, once again, I'm going to paste what I already drew so I don't have to draw it again, save myself a little time there. So this is 67 inches, and now the standard deviation is 2.5. So I'm going to do plus 2.5, which is 69.5, plus 2.5, which is 72, plus 2.5, which is 74.5. I'm also going to go to the left. Now, I don't need the numbers to the left for this particular problem, but I just want to get into the habit of showing you guys how to do it so you're not like, wait, how did I get those numbers? So I'm going to do minus 2.5, which is 64.5, minus 2.5, which is 62, minus 2.5, which is 59.5. And once again, you can use your calculator to get those. I'm just trying to do mental math. If something doesn't make sense when I go to find something, I can say, oh, I messed up and figure it out. All right. Approximately how many students are more than? So I want the probability that X is greater than 72. All right. All right, more than 72. So I'm going to highlight where that is. That's right here. More than 72. That's that right there. So now I just need to know those two areas. If you know those two areas, once again, easy peasy. If you don't have them memorized, you can figure them out. You can say, okay, 68% is, sorry, right, 68. 68% is 34 and 34. I'll show you again in case you forget what they are, right? The next is 95. So if I go 95 minus 68 divided by 2, it's 13.5 and 13.5. This is 13.5 and 13.5. But if you memorize it, life is easier. Next is 99.7. So if I do 99.7 minus the 95, divided that by 2, 2.35 and 2.35. And then if I do 100 minus 99.7 divided by 2, I have 0.15 and 0.15. But if you just memorize those, life is much easier. So now I just want that area, which is 2.35, plus 0.15, which is 2.5%. All right. Now, this question doesn't ask me what percentage. It says how many students, right? So how many is not 2.5%. They originally told me there was 880 students. So I need 2.5% of 880. So I'm going to do 880 times 0.025. 880 times 0.025. And I know that's 22 students. So 22 students scored above, are more than 72 inches tall. I was thinking of the problem before. Okay. All right. Last one like this. What percent of students are between 59.5 and 69.5? I'm not going to draw this again when it is right here, right? So I'm going to copy this, paste this. I'll copy this. Copy and paste. Oh my goodness. Let's delete all that. Paste. I want to save myself a little bit of time here, and it's turning out to be a little bit. Delete that. All right, so now I have this. The only downside of copying and pasting is you're not taking the time to say, okay, this is 34, 13.5, 2.35, 0.15. But if you're telling yourself you have to do that, then you're fine. Okay, so I want to know what percentage is in between 59.5, which is right here, right, and 69.5, which is right here. So that's this. So that is 2.35 plus 13.5 plus 68, or 34 plus 34, right? So 68 plus 13.5 plus 2.35. Enter. And that's 83.85%. Now let's make sure they didn't ask me for how many, what percentage. Okay, so there's my answer. Voila. Okay, so the back side here, we're now going to talk about z-scores, okay? What is a z-score? It says a variable that has known mean and standard deviation can be transformed into a standard score or a z-score. A z-score tells us the direction and the number of standard deviation an observation is from the mean. Okay, so how do we obtain a z-score? So here's the formula to find a z-score. What you're going to do is you're going to take x, which is the data value, and you're going to subtract the mean, and then you're going to take that number and you're going to divide it by the standard deviation. And that tells us all those variables. Here's the formula. And then what the variables are in that chart there too. Okay? So let's say that you had a normal distribution that looks like this. If I wanted to know how many standard deviations I am past the mean or under the mean, that's what the z-score is going to tell us. So let's say I get a z-score of 2.5. That means I am 2.5 standard deviations above the mean. So that means I would lie like right here, okay? If I had a standard deviation, a z-score of negative 0.5, I would lie right here. And that means that I was about 0.5 standard deviations below the mean. All right, so let's see how we can use this in context of a problem. So here it says, Juanita earned 82 on her chemistry, I'm assuming percent, earned an 82 on her chemistry test, where the distribution of scores had a mean of 76 and a standard deviation of 4. The next day, she earned an 86 on her pre-calc test. The class average on the pre-calc test was an 80 and a standard deviation of 6.07. On which test did Juanita perform better relative to the class? Okay, so if you look at this, she got an 82 on her chem test, 86 on her pre-calc test. I'm not asking you what she do better on. Clearly, she did better on her pre-calc test. But I'm asking you, compared to the other students in her class, on which test did she do better? Okay, so let's organize this information here. So for her chemistry test, let's write down what the normal distribution was. So let's see here. So for chemistry, the average was 76 with a standard deviation of 4. Okay, and then for pre-calc, the class average was 80. Looks like 0.80, but it's fine. With a standard deviation of 6.07. Okay, so what we're going to do is we're going to find out her z-score for each of those classes and then say which one she did better on relative to her classmates, okay? So to find her z-score, once again, the formula is to take her score on the test. So on chemistry, she got an 82. We're going to subtract the average, which is 76, and then we'll divide that by 4, okay? This will give us our z-score. So if you're using your calculator to do this, please make sure you do the numerator, 82 minus 76, and then hit enter and get that value, which is 6. Then divide that by 4. That'll give you her z-score. So her z-score is 1.5 for her chemistry test. And then for her pre-calc test, her z-score is, she got an 86 on her pre-calc test. We're going to subtract 80. Remember, make sure you get the numerator first, and then you divide that by the denominator. Otherwise, it'll do, I don't know, it will do 80 divide, it'll do orders of operations. It'll do 80 divided by 6.7 and then 86 minus that, I believe. I'm not going to even try it. So 86 minus 80, hit enter, divide that by 6.07. Yes, that's exactly what it'll do. Okay, and you get the z-score is 3 decimal places in pre-calc, so 0.988. Okay, so the question is on which test did Juanita perform better relative to the class? So if you look, her z-score is higher on her chemistry test versus her pre-calc test. So I'm going to say that Juanita performed better on her chemistry test, performed better on her chemistry test relative to the other students, since or because her z-score of 1.5 is greater than her z-score of 0.988. Okay? So I need to perform better on her chemistry test to the other students since 1.5 is greater than 0.988. All right, one more problem just to make sure we got it. So it says the 2016 World Champions Chicago Cubs had a mean salary of $4,482,745 with a standard deviation of 6 million, blah, blah, blah. Find and interpret the z-score of Kris Bryant's salary if he made $625,000. It's a lot of money, but compared to his teammates, ouch. In 2016. So normal distribution, the mean is 4,482,745, and the standard deviation is 6,166,305. I'm not putting extra commas in, otherwise there's too many commas, which would be fine. I can still read it. All right, so let's find Kris Bryant's z-score. My pen turned off again. Z-score is his salary, $625,000. Yes, $625,000 minus the average, 4,482,745, and then I'll divide that by the standard deviation of 6,166,305. Oops, 305. Okay, 625,123 minus 4,482,745. Hit enter, then divide that by 6,166,305 and hit enter. This will give us Kris Bryant's z-score. We will round to 3 decimal places since this is pre-calc, negative 0.626, right? All right, so now it says find and interpret the z-score. So this is a negative z-score. This means he is earning, just about like right here, right? Less than the average player on the team, right? So we are going to say Kris Bryant salary is 0.626 standard deviations below the mean, or average salary, we could say. I don't have to say negative 6.26 because I said the word below. All right, so Kris Bryant's salary is 0.626 standard deviations below the mean. All right, that's it for today. So just to summarize really quickly, you need to know that how to calculate a z-score, right? You take the score minus the mean divided by the standard deviation. Also make sure that you do the numerator, then enter divided by the denominator. And then also the empirical rule. It's the 68, 95, 99.7 rule. It's also called that. I also highly suggest memorizing these percentages of 34, 13.5, 2.35, and 0.15%. All right, that's it for today. You can go ahead and get started.